introduction, I would like to talk about Ping An a bit more. Ping An Group has been undergoing rapid growth and development. It now has more than 200,000 staff nationwide, and office space is significantly demanded. In an effort to consolidate functions in a single headquarter building, Ping An began construction of the Shenzhen Ping An Financial Center, named PAFC, in 2009, which is targeted for completion 2 years later. The project is being built in the Futian district in Shenzhen, a coastal city near Hong Kong that has expanded its population from 300,000 to more than 30 million in the past 5 years, since it was declared a special economic zone by the government. PAFC comprises 118 levels with GFA of 460 more thousand square meter, accommodating a daytime population more than 20,000 users. It will also have significant sustainability credential with an extremely dense program and well-chosen material and mechanical engineering strategies. PAFC will achieve an 18% to 25% saving beyond sphere standards, and a 46% annual saving in energy costs over a conventional constructed commercial office building of the same scale. The consensus of these factors is by no means incidental. Only through highly coordinated design and communication effort, PAFC project can be realized. This paper highlights some of the past experience. From the start, the owner were determined to have a high-performance, sustainable building that optimized the corporate rail, the focus around 3 main areas: an effective vertical transportation system, an energy-efficient facade, high indoor air quality. The general principles governing the definition of high performance were modeled after the US Department of Energy High Performance and Sustainable Building, HPSB, guidelines. The primary characteristics are quantifiable. Every aspect of the environment performance is monitored throughout the building life cycle. This ranges from computational modeling during the concept and design stages, the specification and implementation during the construction stage, and the measurement and verification during the operation stage. Second, integral. No single discipline alone can provide exemplary performance in all aspects of environmental performance. Hence, the design of high-performance building is an integrated design process where the performance goals are agreed upon, with each party is aware of their responsibility during each stage of the building life cycle. Third, visual. To achieve the costume exemplary performance described above, it is necessary to develop effective means of communication to achieve environmental performance. This is achieved through building environmental modeling, which analyzes the various aspects and presents it to a 3-dimensional visual platform from computer modeling tools. Through implementing this principle, PAFC aims to achieve the Green Building Certification System of Gold rating. The broad vision of PAFC expressed by the architect was that the building would be visually striking with consideration of the demand for a high design occupancy requirement up to 11 square meters per person, and a plot ratio exceeding 20. PAFC will accommodating population of 20,000 employees is stacked on a 72 meter by 72 meter footprint, but it will reduce as it goes up, constrained by the tower's irregular piano-shaped site. The shape of the tower is therefore like that of a taut steel cable pulled to the sky from the ground. Emphasized by the 8 composite mega column that pass beyond the building envelope, its benefits are more than artistic. They are also very practical. The streamline of the tower shape brings measurable benefit in improving structural and wind performance. In all, PAFC achieved a 32% reduction in overturning moment and 35% reduction in wind load compared to Trilico. Due to the shape of the tower, the leasing span can go up to 12.5 meters or more. Throughout the core is packed extremely dense. By way of double-decker elevator with designated dispatch controls, as well as upper local elevator stacked in the same shaft above mid-low zone elevator. The site of the tower is also very important. PAFC is a transit integrated tall building that will occupy a major look in the increasing connection megacity of Hong Kong, Shenzhen, and Guangzhou. It's a home of 120 million people and a third of the China trade value by 2017. Hong Kong and Shenzhen will only be a 15-minute trip by train. In Shenzhen, PAFC is strategically located at the terminus of under construction XRL 9 to Hong Kong, as well as Shenzhen Metro Lines 1 and 3. In essence, the main architectural design moved behind PAFC are as follows. Wind base to increase structural strength, tapered profile to reduce seismic and wind force acting on the structure, shape the corner to improve aerodynamic performance, mega structural system as a means of economic structural resistance, multi-stage vertical transportation to minimize the size of the service core, modular design of the structure and facade system, mass transit connectivity to network with other urban building clusters. Structural design. The PAFC lists a structural design that would be optimized for typhoon wind speed of 60 meters per second, while providing maximum floor space to a tight program. The main structure, therefore, consists of a mega frame, a very solid core wall, strong outrigger truss system. It also complemented by exterior diagonal steel page diagonal bracing. Steel page reinforcing wall are embedded in the structural core up to 12 stories to reduce the overall thickness of the core wall. Two 500-ton tuned mass dampers are located at the 113th floor, maintaining the stability of the tower. PAFC has a unique structural health monitoring system consisting of 428 sensors deliver full life cycle monitoring from construction throughout the surface stages, while land and 3G wireless connections. Data under measurement include climate, seismic, wind load, horizontal displacement of the tower top, deformation, and settlement. Cladding. Once the main structural issue has been overcome, the cladding system has to be determined. The choice of a cladding system would be influenced by its performance under wind load, temperature changes, and building movement, as well as weather tightness against sunlight, water, thermal conductivity. The PAFC primarily adopts a unitized curtain wall system whereby some part of the column are complemented by stone wall from ground to 124 meters in height. And the column from the first floor up to the top are covered by 1.5 millimeter thick stainless steel cladding, weighted 1,700 tons. The selection of linen pattern of stainless steel is aimed to reduce reflection and light pollution, and the material is self-cleaning. The panel consists of 85% recyclable materials. Stainless steel panels are in chevron shape, which not only provide a unique architectural feature, but also provide functional external shading. The overall facade performance is approximately 20% higher than the local code requirements. By adding a daylight stimulation tool against the three-dimensional model of surrounding building and site topography models, the design team determined that the project would have a low shading impact, thereby enable daylight penetration into the building. Low E and high performance glazing is applied to allow sufficient visible light entering the building while reducing the undesirable heat gain. Photo sensor and dimmable lighting device are used to reduce the artificial lighting energy consumption when it's sufficient daylight. Elevator design for customer comfort. The PAFC is held to extraordinarily high standard of energy performance as well as customer comfort, which requires a unique approach to mechanical, electrical, and plumbing engineering, at the same time closely integrated with the design of vertical transportation. One key objective of PAFC is to provide the most effective vertical transportation system with optimized handling capacity and interval period during normal operation. As the initial step, the client, architect, and the system design team have been involved in the decision process of planning of the lift core at the early stage. A total of 80 elevators, including 45 double-deck lifts, serve the building. For optimum service, offices are split into 7 zones, served by 2 intermediate sky lobbies. The 33 local elevator of capacity 1,600 kg move at a speed of 35 to 7 meters per second. The shuttle lift elevators carry up to 1,800 kg, which each deck runs in 9 meters per second. Each of the 7 zones comprises of 8 to 14 stories, depends on the location of the zoning, with the function of pre-designated stop. 2 high-speed lifts run in 10 meters per second are provided to serve the observation deck. The most efficient lifts are those that avoid frequent start and stopping. Therefore, each subzone is served by 4 to 6 double-decker elevator, use of high-speed double-deck lifts enhance the handling capacity and shortening the traveling time. M&E engineering. I will go a bit faster to catch up the time. All the mechanical and electrical plumbing design strategy employed in PAFC work to enforce high performance objective of the building. We have a CO2 monitoring system applying to the AH2 and PAU system, which will detect the concentration of the CO2 content, and which drive the fresh air intake automatically. Primary air unit, air handling unit are completed with total entropy recovering wheel. The unused energy stored in the exhaust air could be recovered to pre-cool the fresh air intake so as to reduce the building cooling load. We have a ice storage system of the capacity of 40,000 ton-hour, which help to reduce 4% saving to energy to the building annual energy cost. Electrical system. We will bring in 9 number of 10 kV electrical cable, including 6 duty and 3 standby, to connect to the switch gear. Also, we are equipped with 6 2,000 kilowatt diesel generator for emergency backup. Indoor air quality. Given the high occupancy density of the building, as well as the high population and motor traffic of the surrounding city, the designer of PAFC undertakes special measures to ensure high IAQ. While facing all sorts of the challenge, the height of the building will prove to be an advantage. So we will manage to improve our IAQ as the heights go up. We also employ CFD analysis to help to analyze the HVAC system and the fire surface smoke extraction system. So we will have overcome all the potential problems involved in the HVAC. The overall energy saving achievement, of the total energy saving, 46% against conventional building, is estimated 27% of the energy reduction achieved has come from compliance of the local energy code. A further 60% energy saving is achieved from the adoption of passive design strategy, including high-performance facade and greenery solution. We also adopt building information management, modeling management to help solving the conflict among the structural curtain wall element and the M&E installation. Vertical transportation management during the construction stage. We adopt to provide construction lift inside the core to facilitate the smooth construction of the curtain wall. Otherwise, there will be a big conflict among these elements. Throughout the construction, we have a little bit of invention to achieve a better and a smooth climbing, concrete formwork, hoist equipment, as well as the beam, steel beam insulation. You can see from the photo. The site management is also a very important issue. We have a carefully planned excavation plan, as well as the superstructure construction. With all this planning, we can achieve 3 to 4 cycles throughout the construction period. I'll take you through the construction progress history. Here we start in 2009, November, we start our excavation. When we come down to the bottom of the excavation where we construct our power cap, we have a ceremony in 2010 December. In 2011 July, our foundation is completed. When the excavation complete in November of 2011, we construct the 3.5 meter wall foundation. 2011 December, we went up to 6 meters. A year later, we went up to 315. In July this year, we are of this shape, 474 meters. As a conclusion, I would like to say Ping An Financial Center has become an outstanding Class A building, which is still taking shape. We are confident that its experience could be shared with the other global tall building project. Since mid-2014, the PAFC has entered an integral stage of simultaneous multi-trade process, including structural, curtain wall, MEP, fitting out, lift, etc. When construction collaboration will be utmost important. With the major challenge of the total project completion ahead of us, we will continue to ensure the quality and safety at the same time. Thank you very much.